A midnight alert flashes red across global observatories. 3I/Atlas, the interstellar visitor, everyone thought would slingshot past, just kinked its path toward Earth by a hair that feels like a guillotine. In control rooms, coffee goes cold, models explode with new lines, and a single word hisses through the comms. Inbound. The sky looks calm, the spreadsheets are on fire. You can almost hear the planet hold its breath, the way a theater goes silent when the orchestra lifts its bows, and no one knows if we are about to hear a lullaby or an alarm. A wall of screens turns into a storm of color. Orbital fitters feed fresh positions to code that has never felt so judged. The first key insight falls like a hammer when something is moving fast enough to ignore our neighborhood's usual etiquette. The tiniest force becomes a steering wheel. A whisper of sunlight on a dark surface, a sigh of vapor from a warm crack. Even the pressure of the light itself can nudge a path from comfortable to complicated. Space is not quiet. It is a constant negotiation conducted by gravity's lawyers and thermodynamics pranksters. Numbers start to line up in thin, suspicious unanimity. A subtle sideways tug shows up in the residuals, those stubborn leftovers, after you subtract what the model expects from what the universe actually does. Usually, residuals are the crumbs you brush off the table. Tonight, they form arrowheads. A junior analyst says it first because junior analysts are the ones still brave enough to blurt the obvious. This thing moved. Not much. Enough. Her voice does not shake, but the room hears the quake anyway. There is no siren for this kind of crisis, just the weirdly polite chime of messaging apps and the white glow of sleepless faces. Someone whispers that interstellar objects do not care about our calendar. Another replies that calendars have never cared about us either. Dark humor is the oxygen of midnight science. The lead dynamicist, a person whose poker face could bluff a statue, leans in toward the plot that matters most. It shows a fan of possible futures, a spray of translucent threads unfurling from the most recent data point. One thread just brushed a blue circle labeled home. The update cadence tightens. Optical observatories report new measurements. Radar arrays swing like searchlights. And a satellite surprises everyone by catching a faint burst of dust lit by the sun. That puff could be nothing more than a patch of surface warming and burping. But at this speed, a burp is a shove. Think of it as cosmic skateboarding. A tiny foot tap sends you toward the curb, and the curb does not move. A veteran controller mutters, "Do not let it be the curb." Phones vibrate on desks with the energy of bees. There is a special ringtone for the kind of call no one wants. It is cheerful. That feels cruel. Across time zones, people wake into a reality where their first task is to persuade their bodies that the adrenaline is warranted. The notes on the whiteboard swing from tidy to feral. Someone draws a line through the word routine. Someone else circles the word drift until the marker runs dry. On the top edge of a monitor, a paper sticky note with a cat doodle stares into the abyss like an underqualified mascot. We step closer to the second insight of the night, the one that sharpens every gaze. Trajectory is not a single line, it is a probability landscape. At any given hour, the object lives inside a cloud of maybes, sculpted by measurement accuracy, model assumptions, and how truthful the cosmos is feeling. Tonight, the cloud leans a degree toward trouble. Degrees in space convert to continents on Earth. The brain tries to scale it with metaphors it should not need. The heart already understands. Outside, the stars are doing their eternal impression of calm. Inside, the conversation is a rapid braid. Update, verify, propagate. Someone says, "Do not panic," which is a reliable way to ensure polite panic. The team slashes through red herrings, clock errors, lens ghosts, calibration ghosts, actual ghosts. The data does not flinch. Across a dozen labs, multiple pipelines agree like cats agreeing about a sunny windowsill. Our visitor twitched. Humor keeps sneaking in like a raccoon with a lockpick. A coder deadpans that the object just wants attention. A spectroscopist replies that there are healthier ways to make friends than high-speed proximity. Laughter lands and leaves quickly. The room returns to its ritual. Listen to the numbers, argue with them, then listen harder. Someone suggests we are seeing non-gravitational acceleration. The phrase feels clinical, like calling a dragon thermal uplift. Correct, and not nearly enough. In the hallway, vending machines blink with the serenity of unhelpful oracles. A young astronomer buys a chocolate bar and forgets it in the slot, too focused on a text from the observatory south of the equator. That confirms another data point. When she remembers the candy hours later, it tastes like victory diluted by dread. Back in the main room, a supervisor goes around replacing empty mugs with water bottles, because even heroes need electrolytes. Crisis looks ordinary from the outside. Inside, it feels like balancing a cathedral on a teacup. A projection of Earth pops up beside the newest trajectory fan. No one says the word impact. No one needs to. Words have mass. If you drop the heavy ones too soon, they crack the floor. Instead, they talk about corridors and windows, about the way a path can thread through a planet's moving target like a needle through a dancer's sleeve. The math is not romantic, but the stakes are. The planet is both stage and audience. Somewhere, a journalist is already drafting a headline they will later rewrite 3 times, and the 4th will be the one everyone remembers. Somewhere, a child points at the sky and asks a parent whether space is dangerous. The parent says space is big. The child says so is the ocean. They are both right, and neither answer is enough. On nights like this, adults reach for tools while children reach for metaphors, and somehow both gestures feel like bravery. The call goes out to assemble the larger circle. More telescopes, more radar, a small fleet of bright minds who know how to turn uncertainty into plans. No one promises a solution tonight. They promise to refuse despair. That is the unglamorous superpower of science. You show up, you measure, you try again, and you keep trying until the universe blinks. If this visitor intends to pass close, we will meet it with numbers sharp enough to shave. By dawn, the plots have stabilized into an uneasy truth. The fan of futures still includes threads that slip by with a safe margin, but the guillotine hair remains, thin and gleaming. The room exhales in shifts, like surf. Someone finally drinks the coffee they poured hours ago. It tastes like burnt hope and necessary resolve. Outside, daybreak looks exactly as it always does, which feels slightly rude. Inside, humanity has moved from not knowing to knowing just enough to worry productively. The night that began with a scream of numbers ends with a vow: we will learn faster than the object moves. Next, we rewind the tape, not for comfort, but for clarity. How we first saw 3IATLAS, and how you catch a stranger in a sky this large without losing the plot or your nerve. Chapter 2. How to Catch a Stranger Star. Rock rewind a few days. As astronomers stitch faint dots into a moving signature, an outsider with a speed that laughs at the sun's leash, we learn how telescopes, surveys, and patient math turned a whisper of photons into a tracked intruder. The joke in the lab: space is big, but gossip travels faster. Catching an interstellar drifter does not begin with a single heroic telescope aimed like a spotlight. It begins with patient sky carpentry. Survey systems sweep vast swaths of darkness every clear night, carving the heavens into tiles and taking short exposures that are long enough to sip starlight, yet short enough to keep fast movers from smearing into invisibility. Each exposure is a noisy postcard. Most postcards show the same stars in the same places, behaving like the world's most punctual extras. What matters are the trespassers, the dots that shift a little between frames, the scratches from orbiting junk, the cosmic ray freckles that photobomb. The first task is separating the interesting from the impolite. Software becomes the night's librarian. It subtracts yesterday's sky from today's, a difference trick that erases the steady wallpaper and leaves behind anything that has dared to move or flare. That creates a messy party of candidates, satellites zipping like impatient fireflies, plane trails doing their runway cosplay, and the occasional moth that managed to argue with a lens. The pipeline flags suspicious pixels, measures their shapes and brightness, and applies a rate filter. Most asteroids drift with the casual pace of neighborhood dogs. Our stranger came in with the stride of someone who already had a second coffee. Too fast, too bright for that speed, worth a second look. The algorithm proposes, the human disposes. A night assistant scrolls through thumbnails, trained to ignore the drama of streaks and love the shy dots that show up in the same place across multiple frames. She links detections into a tiny arc, a micro trail of positions, just long enough to compute a first guess at motion. A second telescope, hundreds of kilometers away, repeats the trick. Now there is parallax, the slight shift you feel when you wink one eye and then the other. With parallax, the distance estimate stops being a shrug and becomes a number the math can hold without dropping. Alert messages leap from the private channel to the shared clearinghouse that tracks new objects. The listing is dry. A provisional label, times, coordinates, brightness in a couple of color filters, and a suggested motion on the sky. Dry is good. Dry keeps the drama out of the file and in the universe where it belongs. Amateur observers join the hunt because the modern sky is democratic. A well-run backyard setup can put real points on the board. Within hours, a loose net of telescopes across latitudes and longitudes has woven a longer arc. With that arc, velocity starts to confess. Here comes the quiet magic. You take the positions, correct them for Earth's spin and Earth's own path around the sun, and compute the object's motion as if you were standing at the center of the solar system. If the speed is modest, you are probably stalking a local rock. If the speed is greater than the neighborhood's escape rule, you have met a traveler with luggage. Our candidates' numbers lean into the second category, not by a razor, not by a rounding error, but by enough to make the room pull closer to their screens. The sun's leash is long. This thing is not wearing a collar. Brightness clues arrive next, and they are gossipy. The object's light, measured through different color filters, suggests a surface that has been tanned by stars we will never see. Some interstellar visitors look redder than the average local stone, as if dust and radiation baked a patina over styles we do not stock here. But color is a slippery witness. It depends on the angle, on whether the surface has spots of darker crust or lighter frost, and on how the object spins. So the team watches for flicker. A regular rise and fall in brightness hints at shape and rotation. Fast flicker points to an elongated body, twirling like a baton. Slow flicker hints at a lazy turn. Our stranger's light curve blushes with a rhythm measured in hours, too calm to be a tumbling shard, too lively to be a perfect sphere. Imperfect is useful. Imperfect tells you where to look next. False positives are the banes of discovery. One satellite flare, pretending to be a visitor, can waste a night. So the team deploys a ritual of skepticism. They cross-check against satellite catalogs, remove detections near known flight paths, and run a cosmic ray filter that looks for the telltale single-frame spike of a charged particle hit. When a candidate survives all of that and still looks like a moving dot with a clear alibi, congratulations, you have an object. And it is not from around here. The lab adopts it with the kind of cautious affection people usually reserve for hedgehogs and mysterious packages. Recovery is the scavenger hunt that can turn a fresh curiosity into a well-behaved path. Once you have the object's likely track, you dig into old images from other nights, sometimes even other years, to find faint, forgotten versions of the same traveler hiding at the edge of detection. Each recovered dot tightens the story. A graduate student, fluent in the dialect of dusty archives, unearths a pair of nearly invisible smudges that aligned perfectly with the backward extrapolation. They are barely above the noise and absolutely priceless. With them, the object's distance and velocity lock in tighter, and the label on the shared board graduates from probable to confident. None of this happens in isolation. A network of observatories hands the baton between time zones. When clouds smother the north, the south picks up the trail. When the big telescopes need daylight to sleep, the smaller ones power through the dusk. A radio dish tries a ping, just in case the surface is cooperative. Spectroscopists prepare to tease chemical hints from the light, careful not to promise more than photons can give. The atmosphere, that wobbly lens we all live under, adds its mischief. So teams schedule bursts of shorter exposures to tame the blur. Every choice is a trade. Longer looks gather more light, but lose sharpness to motion. Shorter looks win sharpness, but flirt with the noise. Catching a stranger is a dance with balances set by nature, not by ego. By the end of this rewind, the object has a tracked path through our sky, a personality sketched in color and spin, and a passport stamped not local. No speeches, no fanfare, just a file that has thickened from rumor to record. The lab's joke still holds. Gossip travels fast, but data, when it travels well, builds the road beneath it. And as the road grows, so does an unsettling question, whispered among keyboards and coffee mugs. Where is this traveler truly headed? Next, we place our new guest beside earlier legends and examine what makes an interstellar visitor behave the way it does. From odd spins to stranger pasts. Chapter 3. The Interstellar Club. Oumuamua, Borisov, and the new guest context. Arrives on cue. What makes something interstellar? Why its speed is weird, and how past visitors rewired our expectations. 3I/Atlas is not a copy. It is a wild card with possible outgassing, odd spin, and a personality problem. Think cosmic tourist who refuses to follow the brochure. Membership in the Interstellar Club is surprisingly strict. You do not get in by being mysterious, dramatic, or photogenic. You get in by moving in a way that tells the sun, politely, that you will not be staying for dessert. Local asteroids and comets are family. They loop the table again and again, sometimes eccentric, sometimes shy, but always returning to the same gravity dinner. An interstellar object is a guest that comes in hot, nods at the sun's invitation, and keeps walking. The tell is speed that remains bold, even after subtracting all the motion of the Earth and the sun. When that speed still says I was made elsewhere, you stamp the passport. The club's first headliner arrived like a rumor that refused to sit down. The world called it Oumuamua, a word borrowed for a messenger from far away. It was dim, small by cosmic yardsticks, and shaped in a way that made the comparison charts sweat. Depending on how you squinted, it was either needle-thin or pancake-wide, spinning in a lazy, lopsided way that would make any physics teacher request a chair. Most maddening, as it receded, it drifted slightly off the path gravity alone would dictate, as if pushed by a very gentle, very invisible hand. No dusty tail, no obvious venting, just a subtle shove that demanded an explanation. Theories auditioned with the enthusiasm of reality show contestants. Maybe a thin crust of trapped gas, maybe a surface so bright that light itself acted like a whispering thruster, maybe something as fragile as frozen fluff. A few voices suggested technology, then remembered the universe has a sense of humor and prefers natural weirdness. Then came Borisov, the second member, who walked on stage and announced, calmly, that it was a comet, not shy about it either. It had a halo of gas and dust, a tail that obeyed the sunlight, and a chemistry that spoke of deep, cold, and long exile. Unlike Oumuamua's baffling restraint, Borisov behaved like it had read the comet manual and highlighted the relevant parts. If Oumuamua was the enigmatic poet, Borisov was the approachable traveler with a guidebook and sensible shoes. Together, they stretched the bounds of what we imagined. One said interstellar objects can be stranger than local rocks. The other said they can also be perfectly ordinary, just from another neighborhood. Enter our new guest, 3I/Atlas, and the club becomes a conversation instead of a collection. The third member matters because 3 points start to trace a pattern. This one carries hints of activity without the predictable theater of a bright tail. It flickers in ways that suggest an uneven body, spinning with a rhythm that refuses to lock into a tidy beat. Its surface signs point to material that has endured radiation and dust in the great in-between, a kind of cosmic weathering that does not get a name in everyday life, because we do not usually sandblast things with starlight for millions of years. Most interesting of all, its motion hints that outgassing could be present, but not in the loud, obvious way that draws a line across the sky. It is more like a set of breathy sighs than a trumpet. Why is speed the headline? Because speed carries origin. A thing made here tends to settle into the family tempo, the way a new dancer learns the steps by circling the floor. A thing made elsewhere arrives with a different rhythm, baked in by whatever star system ejected it. Ejection sounds violent, and sometimes it is. Young solar systems toss material around like puppies with socks. Giants roar through infant belts of rock and ice, and unlucky blocks gain just enough push to leave home forever. Time stretches, distance blooms. The traveler coasts in the quiet dark between stars, occasionally nudged by passing sunlight, occasionally spun by a tiny burst of warmth, frozen into a diary with pages written in texture and chemistry. Oumuamua taught us that shape can be shocking and that non-gravitational nudges can appear without a visible tail. Borisov taught us that alien comets can look comfortingly familiar while still whispering chemical notes not common here. 3I/Atlas arrives as a middle child with its own agenda, hints of venting that refuse to conform, rotational quirks that make modelers frown at their coffee, and a brightness pattern that changes like weather over a landscape. Put simply, it is a personality more than a silhouette. That matters for understanding how interstellar debris ages. Some pieces bake into hard crusts, others stay crumbly, others develop layers like a cake assembled by a geologist. The way an object releases gas, the angles of its vents, the roughness of its face, these become tiny thrusters, painting small strokes on a long path. The Interstellar Club also forces us to rethink population. For ages, the default assumption was that interstellar visitors would be rare celebrity events, once-a-generation happenings. Then rapid surveys sharpened their gaze, and the sky started whispering that the highway traffic might be heavier than we guessed. If 3 arrive within a handful of years, what are we missing at the faint edges? How many travelers skim the outskirts, too dim to flag? The answer matters, not just for curiosity, but for planning. If the void is sprinkled with slow fireworks, you want to know their timing and temperament. There is a cultural shift, too. With every new visitor, public imagination stretches. Oumuamua made people ask if space could deliver mystery without spectacle. Borisov made them realize that alien and familiar can coexist in the same tale. 3I/Atlas invites a different instinct to watch closely, not for drama, but for nuance. Its odd spin is not a headline stunt, it is a diagnostic. Its hesitant venting is not a failure to perform, it is a clue. The humor writes itself. The universe is a great storyteller with terrible punctuality and a taste for unreliable narrators. So what binds this club besides speed? A shared biography of exile. Each object is a shard of somewhere else, a sample return mission run by chance. They carry the recipes of distant kitchens, the ratios of ice to rock, the trace flavors of rare molecules, the scars of star weather. Studying them is less like reading a textbook and more like decoding postcards from strangers who forgot to write their address. You look at the smudges and sunstains and try to infer the beach. 3I/Atlas will not be anyone's copy. It is the friend who says no to the group photo and wanders off to examine the ceiling. That refusal is the gift. It widens the range of what we expect from the next arrival and the next. It informs how we simulate other solar systems, how we estimate the debris fields of planets forming, how we design instruments to catch whispers in the dark. And it sharpens a practical question humming beneath the poetry. If a visitor refuses to follow the brochure, what pushes, tugs, and tricks might bend its path? In our next chapter, we peel back that question and examine the quiet forces that tilt a traveler's road: jets, jitters, and gravity's fine print, because small, well-timed mischief is how the cosmos writes plot twists. Chapter 4: Why the Path Bent. Jets, jitters, and gravity's fine print. The anomaly is not magic, it is physics wearing a mischievous grin. Subtle jets of vapor, dusty vents, and solar heating nudge the object like tiny thrusters, turning a safe flyby into an uncomfortable rendezvous. The universe loves billiards. Sometimes it swaps the cue ball. Picture the surface of 3I/Atlas as a patchwork of temperaments. Some regions are crusty and stubborn, others hide pockets of ice under a thin, dark rind. As sunlight crawls across this landscape, it warms one face faster than its neighbor. Under that crust, trapped volatiles get restless. They do what impatient gases do best. They escape, not explosively, not in a fireworks show, but in steady breaths through cracks, pits, and crater rims. Each breath is momentum with an attitude. Push off a little gas that way, and you get a tiny shove in the opposite direction. One puff is nothing. 1,000 puffs, timed with the day and night rhythm, becomes choreography. That rhythm matters. When sunlight hits a slanted slope, the heat lingers after local dusk, the way pavement stays warm long after sunset. This delay means the object often exhales most strongly when the sun is not directly overhead. The push, therefore, does not line up neatly with the sun. It tilts, producing a sideways drift that a pure gravity path would never choose. Multiply this by a spinning body with bumps and ridges, and the net force becomes a sum of slightly misaligned nudges that, over days and weeks, add up to a meaningful detour. The cosmos is patient. It budgets in whispers. Surface features sharpen the mischief. Imagine a canyon that shadows an icy ledge until the late afternoon. When it finally warms, the vent turns on like a timed sprinkler, then shuts off when the cold returns, or a field of knobbly boulders that bake unevenly, creating hotspots where gas breaks through softer seams. Even dust helps. Fine grains lifted by gentle flow can act like cork in a bottle, briefly sealing a vent and then releasing in a crumbly burst. These start and stop patterns matter more than a steady breeze. A constant push you can predict and cancel. A sporadic push is the cosmic equivalent of a sibling poking your shoulder at irregular intervals and swearing it was not them. Spinning complicates life further. If the object rotates around a tilted axis, the sun paints seasonal stripes across the surface. Some latitudes become long-term hotbeds of venting. Others enter hibernation for stretches. This uneven activity applies not only a shove, but also a torque, a tiny twist that can change the spin rate and tilt. As the spin changes, the patches that face the sun change, which shifts which vents are active, which alters the direction of the shove yet again. It is a feedback loop, like trying to steer a kayak while someone else keeps shifting the seats. The result is not chaos, but it can feel like it on a plot. Then there is light itself. Photons carry momentum, and a dark, lightweight object with a large surface can feel the pressure of sunlight enough to matter. If parts of the surface reflect more than others, the uneven push adds to the venting story. Dust sheaths complicate this further by changing reflectivity as they move. A surface newly dusted becomes brighter, then darkens as grains roll and settle. The push from light is gentle, but gentle does not mean harmless when you have months to integrate the effect. The universe is the master of the long con. Activity does not always mean clean jets aiming from neat round holes. Cliff collapses can expose fresh ice suddenly. A boulder can roll down slope after repeated thermal stress, uncovering a vent that had been plugged for ages. Fragment shedding can happen, where a flake breaks off and briefly trails along, the way a scarf trails behind a runner. The act of losing mass tweaks the motion, and the flake, if it outgasses, adds drag to the neighborhood for a while before wandering off. We tend to imagine smooth spheres. Nature prefers dented projects. Now for gravity's fine print. People love to say gravity is simple. Objects attract. End of lesson. The closing credits hide the footnotes. The pull depends on where you are relative to more than one body. And near a planet, the path can thread through narrow alleys where small adjustments now decide big outcomes later. As 3I/Atlas moves inward, it sails through a landscape of gravitational hills and saddles sculpted by the sun and planets together. A tiny non-symmetric push days in advance can determine whether it passes near a point where a planet's tug focuses the path inward more than expected. That focusing acts like a magnifying glass. It does not invent force out of nowhere. It concentrates outcomes. A near miss of a particular region can be the difference between a wide pass and a nerve-scraping approach. Add in resonances, the quiet rhythms where orbital periods line up in simple ratios. Spend time on the wrong beat, and you can get a lingering nudge in the same direction each circuit. Our visitor is not captured in a loop, but as it crosses the inner system, it still cruises through zones where time spent matters. A slow roll near a planet's risky neighborhood is like loitering at a whirlpool's edge. You will probably be fine. You do not want to dawdle. The map that mission planners draw for such an object uses a special target plane centered on a close approach, a kind of snapshot of all the missed distances and directions that could happen. Inside that plane live small gateways, the infamous narrow spots where a path that glides through on one side is tomorrow's news cycle on the other. The outgassing nudges we described push the path across this plane like a fingertip on a chess piece. No drama, great consequence. And all of it plays out while the object's own internal plumbing evolves. Each vent that gets used tends to frost over later, as escaping gas cools the nozzle, reducing flow next time and routing pressure to another crack. Think of a house with mischievous pipes that redirect the shower every morning. You still get water, it just insists on surprising you. This slow rerouting guarantees that the push you model on Monday is a cousin, not a clone, of the push you will measure on Friday. So the bend in the path is the integrated autobiography of heat and shape, spin and shadow, light and time, gravity and geometry. It is not a single villain. It is an ensemble cast. The joke, if you want one, is that the cosmos builds its loudest plot twists from the quietest ingredients. We only notice when the sum crosses a line our comfort had penciled in. Next, we will chart where such a bend could lead, maps of impact corridors, and the uncomfortable art of deciding where not to stand when the universe is still rolling its dice. Chapter 5: Impact Windows and Where Not to Stand. Analysts pull up probability maps, big blue Earth, tiny red ellipses, impact corridors, snake across oceans and continents, while the clock refuses to pause. We meet the language of risk, where 1% can feel like a thunderclap. The first thing these maps teach is humility. The world looks familiar until you overlay futures on it, then coastlines become margins of error, and cities turn into coordinates that would rather not be cited. The ellipses are not prophecies, they are possibilities. Each one a door the object could choose, depending on how a dozen small factors line up. A corridor appears when you stack those doors in time. It is a ribbon that says, if things go poorly, the visitor will make landfall somewhere along this band. If you have ever tried to predict where a dropped piece of toast will land, then scaled that problem to a planet and swapped butter for cosmic energy, you have the flavor. Risk workers speak a dialect that translates uncertainty into decisions. They do not say never and always, they say likelihood and consequence. A tiny chance paired with a devastating outcome can outweigh a larger chance of something mild. This is why 1% earns respect. 1% means roll a 100-sided die, and do not act surprised when it does not love you. The math is not the message. The message is that low odds do not grant immunity. Lightning does not check your calendar. The windows in question arrive in two shapes: time windows and geography windows. The time window is the stretch during which the path could still tip from near miss to direct hit or vice versa, based on upcoming measurements and the object's own behavior. While that window is open, the red ellipses waver and shuffle like nervous fish. The geography window is the moving band on the globe itself, sliding with Earth's rotation and the object's angle of approach. A corridor that crosses ocean today might slide toward land tomorrow. If you are wondering whether sleep is popular among the people who watch these shifts, it is not. Where not to stand sounds like a joke until someone has to draw a line on a map. If the corridor is narrow, there are places you can cross out with some confidence. If it is wide, caution spills over borders and time zones. Evacuation is not just a question of distance, it is a question of direction. A shallow entry from the west concentrates risk downrange to the east. Mountain ranges change shock patterns and wind behavior after the fact. Coastal regions worry about water being pushed when they would prefer it stayed put. Inland regions worry about ground waves traveling through soft soils. Everyone worries about windows. Altitude at arrival sets the tone. An object that breaks up high spreads smaller fragments over a broad area, creating an airborne punch that flattens things in a ring rather than a crater. An object that holds together longer delivers concentrated harm at the ground. This is the difference between a shout and a hammer. The maps reflect this by showing different kinds of shading: fuzzy swaths for atmospheric events, tighter shapes for ground strikes. People learn terms they never asked to learn. Emergency planners practice sentences that balance honesty with calm, because a community deserves both. Then there is the ocean, the world's vast absorber that is also a prolific amplifier. A plunge into deep water spares landfall, but can send walls of displaced sea racing outward. Shipping lanes, coastal power stations, underwater cables, and fisheries make their own quiet chorus of concerns. No one says the word wave if they can help it. They talk about displacement, about basins, about the tendency of fluids to express strong opinions when shoved in. If the corridor drapes itself over long stretches of water, the question becomes not whether land is struck directly, but which coasts get unwanted visitors hours later. Infrastructure turns out to be allergic to surprise. Even a near pass can deafen a corridor of radio dishes, nudge satellites, and shower low orbit with grit. Because of that, the maps do not only cover ground, they also include shells of altitude, where traffic is heavy. Operators look for safe slots to move their hardware and tug at the right moments. If the object plans to pass through those lanes, the polite term is conjunction. The impolite term is dodge. As new observations arrive, the windows shrink like ice on a stove. That is the good news. The bad news is that they sometimes shrink onto places with postal codes. A city may go from in the broad band to in one of the specific ellipses in a single update cycle. This is why the language of confidence and probability needs translation partners. A mayor does not make choices with decimals. A mayor makes choices with buses, shelters, hospitals, and the patience of tired people. The maps become not only science artifacts, but also logistics tools. They determine which highways run outbound, which air corridors open, which fuel reserves move where. They also dictate media briefings, because rumor will joyfully fill any silence. The human eye loves certainty, so it will search the map for it. The professionals resist that temptation. Instead, they watch the trend. Are the ellipses sliding northward with each update? Are they tightening in length while widening sideways? These movements hint at the approach angle and the object's current temperament. When the band splits into two, it means a fork in the data awaits resolution. When it merges back into one, it means the measurement gods have smiled. The humor is grim but necessary. When the universe gives you breadcrumbs, you measure the bakery. Where not to stand also holds a quiet, ethical puzzle. Corridors cross countries unequally. Some regions have dense networks of sensors and rapid response teams. Others do not. The maps are global, resources are not. So teams build partnerships on the fly, sharing data in plain language, shipping equipment across borders, and translating risk into local context. The goal is infuriatingly modest and vitally important. Help the right people make good decisions at the right time. The applause for that work will be invisible if it succeeds. The final hours, when windows are smallest, feel like trying to thread a needle while the thread argues. But even then, the maps are not prophecies. They are instruments played by fallible hands in a room with crosswinds. That is why the advice stays simple. If told to move, move. If told to shelter, shelter. If told to avoid a horizon, because the sky may arrive at ground level, believe it. You do not negotiate with momentum. You make room for it. Next, we step behind the curtain from maps to messengers. Who gets the call, what is said, and how the alarm is pulled without setting the entire planet on emotional fire. Chapter 6: The Quiet Panic Button. Before the headlines, there is the call list. Space agencies, weather satellites, defense networks, and 3 heads of state trying to sound unflappable. Budgets move at the speed of politics, but physics invoices are due now. Someone jokes, "Can we Venmo the cosmos?" Nobody laughs. The first calls do not happen on the big stage. They happen on secure lines that still click softly, as if reminding everyone that silence can be a sound. A duty officer reads from a laminated card that was designed for a scenario everyone hoped would remain a training exercise. The phrases are careful, almost ceremonial. Status elevated, additional assets requested, prepare for cross-agency synchronization. Translation: stop what you are doing and come hold this rope. An invisible choreography begins. Weather satellites adjust schedules to stare not at clouds, but at vacuum, because sometimes the best weather report is about the absence of air, where air is not supposed to go. Communication constellations are asked to free bandwidth for tracking updates and emergency channels. Ground stations stack time like pancakes, squeezing in extra passes, because when your patient is the sky, you accept appointments at all hours. Defense networks pivot their gaze outward just a little more, because it is polite to watch the street when a stranger is running down it. Then finance wakes up. Finance does not like being woken up. It prefers gentle memos and quarterly expectations. Instead, it receives a single crisp sentence: "We need to move money from later to now." There are funds meant for emergencies, but they come with locks that have many keys. Each key sits in a different pocket. The quiet panic button summons the key holders. They arrive with the expressions of people who were already busy, and suddenly understand the definition. Of busy was an optimistic poem. A pageantry of signatures begins. Waivers are drafted to let engineers buy parts without the usual parade of bids. Contracts stretch like taffy to cover new tasks that did not exist yesterday. Lawyers materialize to ensure that none of this speed will get unmade later by a technicality. They are not here to slow things down. They are here so the future audit will not eat the present mission. The meeting notes do not record the moment when the room collectively decides to pick action over elegance, but the decision is written into every verb afterwards. Meanwhile, the communication strategists build their own launch sequence. They write messages that can travel across languages without losing their bones. No metaphors that might turn into rumors, no numbers without units, no promises shaped like fairy tales. The first draft begins with a phrase that looks harmless and reads like a handrail. We are watching closely. Then come the details. The public has a right to hear, and the details that will only help imitators of chaos. The trick is to be clear without being an arsonist. The second trick is to say it the same way every time. In the back rooms, analysts plot the cadence of updates. Too fast, and you drown people in noise. Too slow, and you fertilize conspiracy gardens. The schedule lands on something human. Morning, afternoon, evening, or if the sky misbehaves, immediately. A plain-spoken scientist volunteers to face cameras because their gift is not just knowledge, it is steadiness. They practice explaining uncertainty without sounding uncertain. The world needs that subtlety. The world is not great at hearing it. Across the ocean of jurisdictions, the quiet button summons memorandums that were signed long ago and then placed in drawers. The drawers open, sharing agreements between agencies that use different alphabets, different cables, and different habits suddenly light up. Data packets begin to cross borders with diplomatic passports. The rules are simple. What helps, flows. What endangers, waits. Someone keeps a ledger because accountability is not a luxury, even on the edge of a cliff. The teams who move bodies and keep order assemble with their own rituals. Transportation planners unroll maps that have coffee rings from 100 lesser crises. They sketch routes that can reverse in an hour if the corridor shifts. Health services review stockpiles and realize that gauze does not expire, but patience does. Power utilities begin the slow dance of preparing for spikes because people will plug in everything when they are scared, including hopes. Education ministries draft lessons for the morning after because children will ask the best questions with the least patience for theater. A small army of translators goes to work. They are the unsung gears of global response. They choose words that mean the same thing everywhere. If the statement says corridor, it must not be mistaken for certainty. If it says window, it must not be mistaken for serenity. The translators argue for elegance and then choose clarity, because elegance is a luxury for calm errors. They test lines with people who do not live in control rooms, and when a phrase causes a frown, it goes back for repair. Cybersecurity has its own quiet button, and it is currently illuminated. When fear is plentiful, malicious creativity is too. The guardians of networks raise shields because a single well-placed rumor can do more damage to a city than a badly placed extension cord. They watch for copycats, for deep fakes with borrowed faces, for counterfeit maps pretending to be official. The defense is not mystical. It is a wall of vigilant humans, backed by filters that catch the worst sand before it clogs the machine. On the diplomatic floor, envoys exchange carefully worded courtesy calls that are really requests for patience. Some nations want to do everything at once. Some would prefer to see proof of necessity inscribed in gold leaf. All of them have schedules, and schedules are proud. The quiet panic button asks them to be humble on purpose. It is not a natural request. It is a necessary one. A veteran diplomat sums it up privately. Sovereignty is a beautiful poem until physics interrupts the reading. In a cavernous hangar, a contingency mission director stands at a folding table that has seen too much coffee and not enough sleep. They review a checklist that includes power, propellant, antennas, and something labeled miscellaneous, which actually means miracles. The director signs with a pen that is both ordinary and historic. Out on the floor, technicians nod once and wheel a crate toward a waiting truck. It is unglamorous in the way bridges are unglamorous, right up until you need to cross a river. Back in the rooms with screens, the night shift hands off to the day shift with a ritual that sounds like an oath. They do not promise success. They promise to keep showing up. The quiet panic button does not glow any less. It simply becomes part of the furniture, a reminder that the planet has entered a moment when emotions must kneel to checklists, and checklists must kneel to evidence. Humor returns for a brief visit, in the form of a sticker on a laptop. Dear Universe, kindly reschedule. The universe does not sign for the note. Tomorrow we'll ask different questions. What exactly are we pushing? How does it hold together? And which touch will change its mind without shattering it into 1,000 smaller votes? For that, we turn to the profile of the visitor itself. Spin, texture, and the rude surprise called fragmentation. Chapter 7, Spin, Shape, and Shrapnel. Knowing the target radar pings, spectral fingerprints, and photometry tease out size, mass, and whether this thing is a fluffy snowball or a grumpy boulder. The model keeps changing like a chameleon in a paint store. If you want to nudge it, you must first know what it is, preferably before you touch it. Step 1 is to make the invisible less mysterious. Planetary radar aims a tight beam, then listens for the echo, as if the universe were a cave and we are clapping once, very loudly. The time delay sketches distance. The way the echo's pitch smears out reveals how fast different parts of the surface are moving toward or away from us. From that smear, you can tell if the object is rotating like a disciplined ballerina or wobbling like a dryer with an uneven load. Stitch many echoes together, and you get a rough silhouette, blocky at first, then sharper, plus a sense of surface texture. A glassy face reflects differently than a blanket of powder. If the return is bright and crisp, think crusted rock. If it is weak and fuzzy, think porous fluff. The radar team summarizes without romance. It looks lumpy. While the radar chatters, telescopes collect the object's light over hours to build a brightness rhythm. This light curve is the heartbeat of spin. Peaks and dips line up with faces turning toward us. If the pattern repeats cleanly, the body is likely a single, steady spinner. If not, welcome to the awkward world of tumbling, where at least two motions mingle and the axis does not hold still. Tumbling matters because a wayward spin turns precise pushes into guesswork. If you have ever tried to tap a spinning coin without sending it somewhere ridiculous, you understand the mood in the control room. Color adds personality. Spectral measurements spread the light into a gentle rainbow. Then ask which wavelengths the surface likes to absorb. Deep, syrupy reds often point to organics baked by cosmic rays. Pale, flat profiles hint at fresher ice or dust. Some spectra show faint lines that whisper specific molecules, a little of this volatile, a hint of that mineral. Thermal infrared reaches for the object's warmth and hands us thermal inertia, a measure of how quickly the surface heats and cools. High inertia means rock or packed crust. Low inertia means powder or snow. Thermal inertia is also a proxy for how it will shed material if struck. A powdery surface coughs, a rocky one spits. Mass is the perennial headache. You cannot put the thing on a scale, and there is no convenient moonlet to tug on. So teams triangulate. If gentle outflows are happening, the resulting acceleration offers a clue to mass. Light bodies twitch more. Radar brightness, thermal behavior, and spin rate hint at density. There is even a trick with sunlight pressure. If the object is suspiciously responsive to light, it might be lighter and fluffier than its swagger suggests. None of these methods alone is satisfying. Together, they trap the answer in a narrowing alley. You end up with a mass range and a best guess, described with the kind of cautious optimism usually reserved for weather forecasts and first dates. Inside the skin lies the question that keeps engineers awake. Is this a rubble pile or a monolith? A rubble pile is a swarm of fragments held together by gentle gravity and a dash of cohesion, like a celestial beanbag. A monolith is a single block with grudges. You can infer this from the spin barrier. If it rotates fast without flying apart, it likely has internal strength. If it refuses to spin quickly, cohesion may be minimal. Radar echo patterns also help. Smoother, single-peaked returns hint at solidity. Multiple speckles dancing across delay channels often betray boulders and cavities. A rubble pile is kinder when you push it, until it is not poke too hard, and you may unstuff the beanbag. A monolith takes a punch, but can crack in dramatic, movie trailer fashion. Pick your anxiety. Surface hazards come next. High-resolution light curves can sometimes betray large boulders if they cast dramatic shadows during occultations. Those moments when the object silently passes in front of a background star and blinks it. A network of observers strung across a continent can record the precise length of the blink from multiple spots, tracing a multi-chord outline like tailor's chalk around a suit. If one chord shows a sudden notch, congratulations, you have a cliff. Cliffs are great for postcards, terrible for landings. Dust is its own subplot. Polarization measurements, how the reflected light is twisted, reveal grain sizes. Fine dust polarizes differently than pebbles. Dust matters because it clogs instruments and turns gentle thrust into unpredictable fireworks. If vents are lifting grains, you can see short-lived halos that play with brightness in measurable, annoying ways. The team logs it as activity-induced photometric noise and then buys more coffee. Now the shrapnel question. What happens when you actually tap this thing? Ejector behavior depends on gravity, cohesion, and local texture. Powder launches in a cone, falls back slowly, and coats everything like gray confetti. Pebbles ricochet and can become unwelcome satellites for a while. If the surface has icy cement, the first hit may excavate a volatile layer, turning the site into a temporary garden hose. You also worry about secondary fragments, pieces that break free and then decide freedom is a lifestyle. Models simulate these outcomes with fields of particles that bounce, stick, and sometimes sulk. The practical output is a no-go list for approach angles and a menu of expected messes. All this feeds a living shape model, the digital statue of our visitor. With each new radar pass and light curve, artists who speak mathematics refine the facets, smooth an edge here, add a notch there, tilt the spin pole a little towards sanity. The model is not art for art's sake. It is the canvas on which guidance teams paint rendezvous paths and targeting points. You choose a spot to aim because it is flat enough, strong enough, and unlikely to behave like a popcorn kernel at the worst possible moment. The model also informs how big a shove translates into how big a detour. A push near the equator of a steadily spinning body is different from a nudge near a tilted pole on a tumbler. Some measurements will contradict others. That is not failure. That is a clue that the object is moodier than a lab manual. When thermal data says powder and radar says crust, you may be looking at a patchwork, hard plates stitched over softer fill. When spectra show hints of volatile frosting, but the light curve stays calm, vents may be tucked into hollows that do not face us often. You resolve these puzzles not by picking favorites, but by designing tests that force the object to choose a story. Change the observing geometry, polarize the light, watch through sunrise and sunset on its surface. Patience is an instrument too. In the end, you do not get certainty. You get enough truth to make a plan, enough to decide whether to tap gently, push firmly, or bring a bigger idea, enough to predict what kind of tantrum the surface will throw when you touch it, enough to turn fear into engineering. And with that dossier, we can finally talk strategy. Not in slogans, but in carefully measured ways to move a mountain, by whispering at the right place and time. Next, the toolbox for nudging, from quiet companions to deliberate shoves, and how to choose the right glove for a very alien elbow. Chapter 8, Nudge Theory 101. Push, pull, or paint it. Options: hit the whiteboard, kinetic impactor, gravity tractor, albedo tricks with reflective dust, and yes, the loud option with a countdown. Each method gets a reality check for time, thrust, and try not to make it a shotgun. The golden rule: small pushes early beat, heroic saves late. Begin with the simplest verb in space, tap. A kinetic impactor is a spacecraft that arrives with no small talk and a very deliberate bump. The point is not to break the target into drama confetti. It is to exchange momentum in a clean, predictable way. You line up the strike a little off-center to encourage a sideways drift, then let the object's own path amplify your courtesy over time. The fine print is the surface. If you hit crust that crumbles like stale cake, a lot of energy goes into making a dusty moment rather than a useful push. If you hit solid rock, you get a tidy recoil, but also a risk of cracks that change the object's mood. The success metric is not the plume. It is the trajectory that inches away from danger, like a cat deciding to forgive you. Next up, the gravity tractor, which is either the cleverest idea ever or a cosmic staring contest. Park a heavy spacecraft near the object and hover gently. Gravity does the actual pulling, like a slow tugboat nudging a freighter without touching it. The beauty here is control. No debris, no surprise vents, just a steady, polite tug that can be dialed up or down by adjusting distance and mass. The drawback is patience. You need time, and in space, time is the most expensive propellant. Also, hovering is not a casual hobby. You burn fuel to keep your tug from drifting or kissing the target by accident. Even so, the tractor wins elegance points. It is the space equivalent of persuading rather than shoving. If you cannot add a big mass, you can fake it with persistence. Then to the ion beam shepherd. Imagine a spacecraft aiming a stream of fast ions at the object's surface, like a hairdryer with delusions of grandeur. The beam imparts momentum without contact, and because the push is distributed over a patch, you avoid drilling one angry hole. This approach loves a cooperative surface and a stable hover. It hates dust storms and surprise venting. You need reliable power to keep the beam humming, which means large solar wings or an onboard power source that does not mind the deep cold. The joke among engineers, it is basically space leaf blowing, except the leaves are ancient and grumpy. Painting is not a metaphor. Painting is painting. Change the surface reflectivity, and you change how light pushes. Dusting the object with bright particles increases the push from sunlight. Sprinkling dark grit decreases it. Either way, you are turning photons into tiny thrusters that work all day, every day. The upside is simplicity. The downside is distribution. You must coat enough surface to matter, and you must do it evenly enough that you do not accidentally create a spin tantrum. There is a bonus concern. The universe is windy at small scales. Dust likes to move. You finish the job, and the object decides to sneeze. Plan accordingly. Lasers promise drama with receipts. Aim a focused beam at a patch of surface and let it heat until material leaves quietly as vapor. That outflow is a controllable jet you can turn off and on. With a fleet of smaller laser craft, you can mix directions for finesse the way a string quartet bends a note. Problems include power, cooling, and the awkward reality that you are deliberately cooking an object that might hide volatile pockets. Imagine toasting bread when the loaf might contain a surprise firecracker. You proceed, but you keep the oven mitts on. Now for the option that clears meeting rooms. Nuclear standoff. Detonate at a safe distance so that intense light flashes the surface, ablating a skin of material into a fast jet that pushes the rest away. Done well, it is a big shove without breaking the target into a swarm. Done poorly, you could make a cloud that turns one problem into many small, rude problems. The ethical and political baggage is substantial. The technical challenge is to choose a distance that maximizes push while minimizing tantrum. This is the late game card, not because it is crude, but because it is consequential. It is the one you hope stays in the deck. Some concepts sound like science fiction until you realize engineers already built versions of them on Earth. A mass driver lander would anchor to the surface and spit small pellets or local regolith in a steady stream, turning mined material into reaction mass. Think snowblower, but the snow is destiny. The benefit is efficiency. The drawback is landing on a place that resents visitors. Anchors must bite, motors must not clog, and the device must survive its own exhaust carving new real estate beneath it. Tethers offer a peculiar form of elegance. Attach a weighted line and let rotation do work. When released at the right moment, the counterweight carries away angular momentum, while the main body gains a delicate change in path. You would not try this without a deep understanding of the spin state and surface anchors that behave. The image is ridiculous and wonderful, a cosmic bolo that edits a future headline by a few careful meters. Every method lives or dies by schedule. Early means options. Early is when a teaspoon of push becomes a continent of miss later. Late means force, and force invites side effects. So the whiteboard includes timelines as large as the arrows. How long to build, how long to cruise, how long to operate, and how long for the push to grow into a safe gap. The math sits beside the mundane. Launch pads, supply chains, people who can wire harnesses while keeping their hands steady. Red teamers prowl the plan with delightfully gloomy energy. What if the surface is softer than predicted? What if the spin changes halfway? What if the object decides to shed a cousin at the worst possible moment? These questions are not sabotage, they are insurance. Each answer adds a fallback, a secondary target point, an extra tank of propellant, a switch from push to pull if the dust gets rude. The golden rule is not a slogan on a poster. It is the spine of the schedule. Small pushes early beat heroic saves late, because early lets you steer, late makes you wrestle. And throughout, one phrase keeps the temperature honest. Do not make it a shotgun. Fragmentation is the ghost at every feast. Techniques that distribute force, that push gently but persistently, that keep the object in one piece while changing its mind, those get the respectful nod. The loud card stays in its sleeve unless the clock insists. All of this theory must become hardware in a hurry. Whiteboard arrows are not thrusters. Next, we sprint from plan to factory floor. How to build a mission yesterday. Shave mass like a barber and thread a launch window that refuses to wait. Chapter 9. Build a mission yesterday. Engineers sprint. They strip mass from spacecraft, raid parts bins, and adopt a design philosophy known as good enough, tested twice. Launch windows are temperamental. Rockets do not care about our feelings. This is speed-running aerospace with the cheat codes turned off. Day one begins with a brutal inventory. What do we already have that flies? Flight computers with recent heritage, star trackers that survived vacuum tantrums, reaction wheels that do not squeal, radios that can shout across cruel distances. The procurement team becomes a treasure hunter in a warehouse maze, scanning serial numbers like archaeologists in hairnets. New designs are a luxury. Proven parts are gold. When the clock is hungry, you feed it reliability you can point to. The vehicle diet starts immediately. Every gram must justify itself like a contestant at a harsh talent show. Fasteners are swapped for lighter alloys. Cable runs are rerouted to shave centimeters. A bracket loses a corner and then another, until it looks like lace made by a very nervous artist. The structures team performs their sacred ritual. Remove material, run analysis, stare at a screen until someone says it will hold, then remove a little more. Weight saved here becomes propellant there, and propellant is destiny. Configuration control goes from a tidy flowchart to a religion. In normal times, paperwork is a polite guardrail. In crisis time, it is life support. One drawing, one truth. If a connector moves on the bench, the document changes before lunch. People roll their eyes at process until the day a mislabeled wire cooks a board. That is why there is a person whose only job is to make sure the right version of reality is in everyone's hands. They are not glamorous. They are the reason the spacecraft wakes up instead of sulking. Testing strategy gets rewritten with a stopwatch. There is no time for theater, but there is always time for failure to sneak in. So the mantra becomes test what can kill you, simulate what can annoy you, and accept what can only mildly embarrass you. Vibration tables thunder early to shake out loose screws and fragile egos. Thermal chambers run day-night cycles that would make a desert jealous. Vacuum tests confirm seals, because nothing says awkward like a spacecraft that cannot breathe the nothing it was born for. The team drops full dress rehearsals in favor of targeted sprints where each subsystem proves a specific promise twice. The second pass is not paranoia, it is respect for Murphy, who never sleeps. Software evolves like a creature chased by a flood. Developers lock the minimum features that navigate and point, then build layers around them. No clever graphics, no vanity modes, just robust autonomy that can handle lost stars, mixed signals, and a sensor that decides to be dramatic in mid-course. Simulations feed it nightmare fuel, false horizons, delayed commands, random blips that look like cosmic hiccups. The onboard fault manager learns to be strict but not hysterical. If it throws a safe mode at the wrong moment, guidance will write a strongly worded letter. Supply chains are the new boss. Exotic alloys do not care about urgency. They care about mills and back orders. So the materials team phones partners who can swap in alternatives with similar temper and less drama. The phrase acceptance by similarity gets more airtime than anyone likes. Backed by a dash of analysis and a vow to do a focused test. Meanwhile, the clean room hums with filtered air and strained jokes. Contamination control officers wield particle counters like wands. A single fingerprint is a confession, and the penalty is more wiping than a new parent's week. Power is the quiet tyrant. Panels must fit within a fairing outline that is already claustrophobic. Batteries must endure long nights and sudden thirsts. Harnesses must carry current without becoming space heaters. The power team does arithmetic so often they can hear it in their dreams, trading margin for mass and back again. They also design a quirk, a mode so miserly it keeps the craft alive on crumbs if something goes sideways. It is the space version of living on instant noodles while the fridge is repaired. Communications engineers negotiate with physics and ground stations in equal measure. They size antennas to speak softly at launch and strongly at cruise, choose frequencies that will not step on anyone's toes, and book network time like a festival organizer. Links must close with a spacecraft that could be frightened, spinning, or shy behind a plume. Modems rehearse the handshake ritual in hardware loops until the bits flow like gossip. Guidance and control builds the choreography. There is a targeting point on an alien rock, and that rendezvous is a dance no one can practice on the real floor. Star trackers learn the constellations the mission will actually see. Gyros are paired with algorithms that distrust them just enough to notice when they fibbered. Thruster valves click through pulse trains that would make a drummer proud. Every micro burn must behave, because at high speed, small errors throw long shadows. Integration is where plans become arguments with gravity. The propulsion module meets the bus on a lift that creaks delicately. Ground support carts hiss as lines fill with noble gas and ambition. Technicians read checklists aloud like spells. Someone drops a wrench and time stops until it is located and logged. The payload bolts on last, covered in a blanket like a shy celebrity. When the protective film peels away for a final inspection, every headlamp catches motes in the air that are promptly hunted to extinction. The rocket team runs parallel sprints. They retime a manifest, reshuffle customers, and negotiate with a weather pattern that refuses to sign contracts. Range safety sets rules that are not negotiable. Keep the sky clear. Tell us when you blink. Prove your self-destruct. We'll listen, even if everything else refuses. The fairing halves close with a muted thud that sounds like commitment. Once sealed, the spacecraft is a rumor inside a shell. Operations rehearses on consoles that will soon be very real. Scripts are written with more white space than poetry, so frightened hands can find the next line. Voice loops get etiquette. Short words, calm voices, no hero monologues. The launch day playlist is optimistic and slightly superstitious. A mascot appears on a workstation because humans insist on totems when piloting expensive courage. When the rollout happens at dawn, the vehicle looks indifferent, which is its job. The team watches from a safe distance, suddenly quiet. Years of training condensed into months of frenzy now depend on valves, lines, and the polite violence of controlled fire. If luck is merely well-prepared physics, then luck has been sweating along with everyone else. When the rocket leaves Earth, the timeline switches from build to prove. Next comes the public stage, whether we like it or not. Streaked skies, open feeds, and narratives that mutate faster than command sequences. Chapter 10 opens the door to that world, where the sky goes viral and clarity must outpace noise. Chapter 10, the sky goes viral. Phones aim upward, live streams bloom, and misinformation sprouts like mushrooms after a thunderstorm. Memes call it space's midlife crisis. Conspiracy channels call it everything else. Communicators try a new tactic, radical clarity, plus one delightful cat graphic that explains momentum. The first wave is pure spectacle. Night skies pick up a faint, moving spark, and every rooftop becomes a micro-observatory, with pizza boxes for tripods. A chorus of "Do you see it?" rolls across neighborhoods like an echo test for civilization. The moment someone adds dramatic music to a shaky clip, the algorithm decides it is buffet night. Views skyrocket. So do rumors, secret weapons, divine comebacks, hidden planets auditioning for main character energy. One post insists the glow is a force field. Another claims it is not real because their cousin's camera did not see it. Evidence must now compete with confidence, and confidence brought a megaphone. The official channels pivot from press releases to threads that read like text messages from a calm friend. Short sentences, plain words, a single image that tells a story better than a stack of serious charts. Enter the cat. It pads across a looped animation, bumping a toy ball to show that a small push early makes a bigger change later. The caption says momentum without equations. People share it because it is cute. They keep it because it makes sense. Somewhere a physicist wipes away a proud tear with a lab coat sleeve and pretends it is dust. Radical clarity means burning jargon at the stake and saving only the useful ashes. Instead of non-gravitational perturbation, they say gentle puffs that steer. Instead of uncertainty ellipse, they say zone where it could go. Each post includes a timestamp in universal time and local time. Because confusion loves clocks, accessibility becomes non-negotiable. Alt text for every image, captions for every clip, transcripts for every briefing. An interpreter signs beside the speaker, hands turning orbital mechanics into a language that needs no microphone. A rumor control team stands up like firefighters who specialize in pixels. They track the myths that spread fastest and answer them with respect, not mockery. A viral claim says the object will cause earthquakes on demand. The reply explains that space rocks are great at drama, but terrible at plate tectonics. Another post insists governments are hiding a bunker schedule. The reply lays out the public contingency steps, the schedule for the next update, and the phone numbers that ring on purpose. The rule is simple. When nonsense is loud, truth must be easy to find and slightly louder. Creators become unlikely allies. A skateboard vlogger breaks down entry angles with a whiteboard and gets more reach than a week of stern broadcasts. A teacher performs a backyard demo with a hairdryer and glitter to show how light can push on a surface. The comments section decides this is a vibe and asks for more. Science communication stops being a lecture and becomes a duet. The professionals supply fresh, verified facts. The internet supplies metaphors and a taste for chaotic sincerity. Dashboards appear, clean as kitchens in appliance commercials. A single page shows the current path, the next measurement window, and a traffic light-style risk meter that refuses to go beyond what the data will bear. No secret tabs, no spooky countdown clocks, just the kind of calm design that makes your heart rate sit down. The meter does not jump to red because fear asks nicely. It moves only when new measurements demand it. Underneath, a changelog records what shifted and why. Transparency is not a hobby, it is strategy. Memes, meanwhile, are busy doing cardio. Some are harmless. Space Rock asks for directions, gets lost, tries Earth. Some are mean, blaming random groups for gravity's hobbies. Moderators earn their keep, posts that target people get buried, jokes that teach survive. A running gag compares the object to a cat. Independent, ignores instructions, occasionally yells at the door. The cat graphic returns for a cameo, and because this is the internet, gets fan art. Somewhere, a communications lead updates a slide titled "Leaning into the Cat" cautiously. Live streams from observatories turn the late night into a global balcony. A host in a sweater you instantly trust narrates the sky's slow punctuation. The chat scrolls by at comet speed. Is it bigger now? Say hi to Brazil. My dog is concerned. What is momentum again? The host answers the last one with a prop skateboard and a polite glide across the floor. A science class sneaks in through entertainment's side door, and everyone pretends not to notice while learning on purpose. Crisis hotlines add a new menu item. Press 3 if you want accurate updates about the object and local guidance. Volunteers trained in calm voices and verified scripts take calls from people who need to hear a human say the plan out loud. Languages network out like tree roots, each community voice translating what matters into what fits, avoiding idioms that do not travel well. When one translation turns impact window into appointment, they fix it before breakfast, thanks to a grandparent who called to ask if the sky requires a calendar invite. Brands try to be helpful, and the internet tries to be patient. A sandwich chain offers trajectory subs, which is cheerfully ignored. A sports team promises to rename itself the Deflectors if things work out, which gets a chuckle and then a stern reminder that mission teams already have a name: busy. The best corporate post is a simple one from a power company explaining how to prepare for temporary outages just in case, without spooky music or sales pitches. Practical beats flashy every time. Behind the scenes, the communicators measure their own performance. Which explanations reduced questions rather than generating new rabbit holes? Which graphics traveled cleanly between platforms without mangling context? They publish a meta update, not to brag, but to show their work. Expertise is not just knowing, it is showing how you know. Trust is a muscle. Tonight, it gets a workout. By sunrise, the world is strangely synchronized. A farmer in the plains, a nurse on night shift, a coder in a tiny apartment, and a kid with a recycled telescope all know when the next update lands and what it will mean. The sky has not changed color, but people have changed posture. Less craned necks in fear, more steady breathing with eyes open. Radically clear beats vaguely grand, every time. Next comes the hardest precision act in the show, aiming for a moving pebble from a spinning rock. Mid-course corrections, guidance nerves, and a choreography that turns math into motion, because the internet can adore a cat, but the spacecraft still has to nail the shot. Chapter 11, aiming for a moving pebble from a spinning rock. Mid-course corrections thread, a cosmic needle. Guidance teams choreograph burns while the spacecraft naps and wakes on cue. The plan, hit 3IATLAS slightly off-center, like nudging a bowling ball, so it obeys peer pressure. First principle of pursuit: you do not chase the target, you chase where the target will be after both of you have finished being dramatic. The spacecraft flies a path shaped by earlier decisions, and tiny engine whispers. The visitor flies a path shaped by sunlight, surface quirks, and whatever new habit it picked up yesterday. Between them sits a schedule of corrections, each one a brief nudge that trades propellant for precision. The artistry is not in the size of the burn, but in its direction and timing. A well-aimed teaspoon now is worth a truckload later. That is orbital etiquette and fiscal responsibility rolled into one. Navigation is a two-act play: measure, then move. Measuring begins with optical nav, snapshots of the visitor against a sprinkle of background stars. Stars are the fixed pins on the lane. The faint speck is the ball you are trying to influence without touching the floor. Software identifies the stars, subtracts them from the image, and isolates the speck with a patience that would impress monks. Each measurement is a point with a quiet confession of uncertainty. We string enough points together, and a path appears that you can actually steer toward. But the visitor is not a light bulb on a stick. It rotates, its brightness breathes. At some angles, it seems to wink just to keep the room humble. To manage that, the team schedules image bursts around predicted moments when glare is minimal and the phase angle is kind. If the object turns a boulder toward us and the light curve dips, the algorithm does not panic. It shrugs, archives the surprise, and waits for the next clean look. Navigation, like good jazz, respects rests as much as notes. While images trickle in, radio tracking anchors the bigger picture. Deep antennas listen to the spacecraft's tone, sliding slightly as distance changes. That slide, measured over hours, sketches range and line of sight speed with a calm that borders on smug. Combine radio with pictures, and you get a position solution that feels less like a guess and more like an address. The math that blends it all has a fancy name, but the vibe is simple. Trust each sensor the right amount and no more, and always be ready to change your mind when new truth arrives. When it is time to move, thrusters take the stage. They do not roar, they tick. Pulses measured in moments tilt the path by hair widths that grow into kilometers downstream. Each correction is rehearsed in simulation, then loaded as a script with generous checkpoints. Before the burn, the craft rolls to show the engines the proper way, confirms tank pressures like a nervous chef checking the oven, and asks the inertial sensors one last time if up is still up. Then the valves open, the numbers walk toward their targets, and a small miracle happens. Momentum accepts new instructions without a tantrum. Sleep is strategy, not laziness. Between burns, the spacecraft parks itself in a quiet attitude that keeps the radiators happy, the panels sunny, and the antenna politely aimed. A timed alarm pulls it back to alertness for the next photo set or engine whisper. Every wake cycle includes a wellness check: star camera sanity, gyro honesty, thermal comfort. If anything sulks, the fault manager steps in with the energy of a kindly bouncer. Sit down, cool off, try again. Only if the misbehavior persists does the craft slip into a safer, simpler mode where it can wait for advice from Earth. Because the target is spinning, the aim point on its surface is a moving parade float. You do not simply pick a spot, you pick a time, and a spot that will be in the right place at that time. The guidance team builds a schedule that looks like a choreography sheet. At this minute, target latitude, such and such. A handful of minutes later, the limb crosses here. A pinch later, the safe off-center zone rolls into view. The camera confirms the pose, the computer counts down, and the final correction leans the craft into the strike, like a fencer choosing the exact moment to extend. There is also the subtle business of off-center intent. A dead-center hit would broadcast energy inward. A slight offset encourages a sideways change that is more useful for steering. The sweet spot is wide enough to hit under stress and narrow enough to avoid a spin surprise. Think of it as tapping a spinning globe, so the new path is more whisper than wallop. The rule is simple: change direction, not personality. Mid-course work rewards restraint. Too many corrections, and you waste propellant and chase your own tail. Too few, and you arrive with bravado and bad aim. To manage that, the team keeps a correction budget, slicing it into a handful of planned opportunities with small reserves held back for final polish. Each successful tweak relaxes the next one. Each messy tweak tightens the shoulders around the room and steals margin from tomorrow. Nobody wants to be famous for the correction that made the next correction heroic. The corridor to the encounter has its own weather. Solar activity can sprinkle the radio link with static. A micrometeoroid might lightly kiss a panel and rattle a sensor. The plan anticipates tiny storms by doubling up on measurements and building quiet hours where the craft stays still long enough for the flight dynamics folks to breathe and verify. Rushing is for drama. Pausing is for accuracy. As the distance shrinks, the images fatten from speck to shape. Landmarks appear, a ridge here, a dark patch there, a glint that could be a smooth slab. The targeting algorithm graduates from aim for the centroid to aim for that particular shadow that will be there 2 minutes from now. The final correction is measured in size. Engines tap once, twice, then nothing. From here, geometry does the last of the work. The last checklist before contact is part technical, part psychological. Confirm velocity aim. Lock camera. Arm the recorder that will send home the moment everyone has been building toward. And then a line that lives on every mission for reasons that border on spiritual. No further changes unless safety demands it. There is a point where a plan must be allowed to be the plan. You would think the room would erupt early. It does not. People sit very still and listen to tones and watch numbers and wait for a timestamp to clear the light speed delay. When it does, the first reaction is not a shout, but a release, like a building exhaling. Then the whoops arrive, gladly late. Next, we leave the language of aim and enter the language of touch. What it looks like when a silent fist meets an ancient surface, how the plume tells the truth about recoil, and how a planet full of screens learns to hold its breath together. Chapter 12, Touching the Alien. The impactor arrives first, a silent fist meeting a cold, ancient face. Instruments watch the plume and measure the recoil like a forensic team in zero gravity. On Earth, a server farm drinks an espresso and updates the odds. Humans hold their breath without being asked. Contact is not a bang. It is a change in the book-peaking of motion. For a blink, the universe looks the same. Then a glitter of dust rises, thin at first, then thick, a shawl pulled from the surface and thrown into sunfire. Telescopes catch the initial flash as a brief brightening, the cosmic version of a wince. The light curve bumps, dips, and steadies. Somewhere, a guidance engineer whispers to no one in particular, "We touched it." The plume is the witness who saw everything. High-speed fragments shoot outward on straight lines. Slower grains lift, hesitate, and curl back toward the body's weak gravity, like regret. Cameras tuned to different colors peel the event into layers. One band shows pale, sunlit flour, another reveals darker chunks with ancient crust. A thermal imager paints the hot throat of the impact site as the surface, suddenly awakened, radiates away its surprise. If there were any volatile pockets in the strike zone, their breath adds a faint halo that swells, thins, and vanishes. Space has no sound, but this looks loud. Back in the object's shadow, a tiny chaperone spacecraft watches from a safe offset, a paparazzo with excellent manners. Its job is to film, to sniff, to time. It tracks the cone of ejector, measuring angles and speeds, the way a traffic camera times a yellow light that everyone swears they made. Polarization filters tell grain size by how the light twists. Radar glances off the growing cloud and returns a smeared echo that encodes chaos, pebbles, dust, and a few pieces that really should have worn helmets. Momentum is the currency of the day, and the accounting is fussy. The impactor brought its own share, but the plume can add a bonus. If enough mass flies out the front door, the recoil is larger than the fist alone could provide. Analysts call this the momentum multiplier, and they chase it by summing the motion of everything that left home in a hurry. The early estimate arrives in the form of a sober sentence. The push was meaningfully larger than the bare impact. Translate that into human. The nudge walked farther than its footprints. On the object itself, the strike edits the spin. A tiny change measured in fractions of a turn per day shifts the way sunrise crawls across the surface. A ridge that woke to morning light now sees a slightly different noon. A vent that used to nap in the afternoon gets a new alarm. The chaperone tracks subtle wobbles by watching landmarks patrol across the limb. These are not cosmetic details. They are clues about how the interior carries stress and how the surface remembers being punched. Dust, liberated from antique bonds, becomes a new environment. Some grains settle back, repainting the nearby terrain with a fresh coat that covers old scars and creates new ones. Other grains find just enough energy to escape into their own steep little orbits, forming a temporary bracelet of grit that the chaperone must tiptoe through. Navigation updates add exclusion cones and polite phrases. No one wants to explain that the mission ended because of a pebble with poor boundaries. On Earth, the data waterfall begins. Streams of numbers arrive through deep antennas and sprint into racks of machines that hum like beehives with a sense of purpose. The first plots are quick and dirty. Plume angles, brightness rates, timing stamps, checked against the relentless arithmetic of light travel. Then the big engines kick in. Models digest the images, compare them with preloaded terrain maps, and solve for the shift in the object's path. Computers are not emotional, but there is a moment when the predicted missed distance grows past a threshold, and the server room feels warmer. People, scattered across time zones, experience the event in layers. The watch floor hears the confirmation tone and claps once. The ritual of professionals who know the story is still being written. The public live stream shows a time-delayed sequence of the dust blooming and a host explaining that you would not hear anything if you were standing there because this neighborhood does not do air. In living rooms, friends text each other variations of "did that actually work?" A child asks if the rock is mad. The parent says rocks are very forgiving when shown the right direction. Scientists who trained for restraint allow themselves tiny celebrations. A spectroscopist circles a faint line in the post-impact spectrum that hints at a buried layer now tasting sunlight for the first time in ages. A thermal mapper writes a note to themselves about how fast the heat bled away, because that speed whispers about density just beneath the skin. The radar team debates whether a faint second echo means a slab flipped or merely blinked. Debates in science are slow dances. Tonight, they have the tempo of pop. The impactor, having completed its one heroic trick, becomes part of the landscape it changed. Its crater will not be pretty by Earth standards, more of a scooped scratch with rough lips and a field of debris around it. But pretty is not the goal. Effective is. The chaperone steals a few final oblique images before a scheduled retreat burn, not out of fear, but respect. You do not linger near a place that is still deciding how to settle. There is housekeeping to do. Mission operations toggles the spacecraft into a thriftier mode to bank power for the next tracking session. Fresh hazard maps for the dust environment propagate to every console. The press office releases a 2-line update that reads like a haiku of relief and restraint. Impact confirmed, plume observed, trajectory assessment pending. The internet adds captions and turns the plume into art before the official diagrams are even exported. Through all of it runs a thin thread of humor, too modest to be noticed by anyone outside the rooms. A sticker appears on a laptop. Please enjoy your complimentary course correction. Someone draws the crater on the whiteboard and names it after a teen dog that sleeps through meetings. Laughing is not disrespect. It is breathing while doing math. By the time stars reclaim the sky above the ground stations, the first refined trajectory solutions arrive. They carry error bars that look much smaller than yesterday's, and a line that bends just enough to change the tone in 1,000 throats. The numbers do not promise a happy ending. They promise a direction that makes one possible. Next, we turn from theater to arithmetic. How those lines settle, what the new odds really mean, and how success can be real and still not be enough. The chapter after a punch is always the one where the calculators sing. Chapter 13. Aftershock Math. Did we move the mountain? Trajectory solutions settle into a new shape, and the red ellipses wobble, Some risk corridors shrink. One stubborn line refuses to die. The uncomfortable truth of space. Success can be real and still not be enough. Post-impact navigation is a patience test disguised as a graph. The first data splashes in with confidence that looks tall until you notice the ladder of caveats leaning against it. Observatories around the world feed angles and timestamps into a blender of careful math. The recipe is familiar. Take fresh positions, remove Earth's fidgeting, fold in solar pull, sprinkle in radiation pressure. Then bake in a computer that can do 1,000 what-ifs before the coffee cools. Out comes a new family of futures, thinner than yesterday's, but still wide enough to host a few bad ideas. Analysts do not cheer at lines, they cheer at shrinking shadows. The solution cloud has a spine, a thin pathway along which the uncertainties prefer to dance. It is called the line of variation, and tonight it is the narrow road everyone wishes would take a vacation. Most of the road now detours well past us. One segment does not. It keeps tracing a polite, persistent path through an awkward region, like a guest who refuses to notice that the lights are off and the host is standing in pajamas. Weighing the new truth means balancing instruments against each other, like opinionated relatives at a dinner table. Optical astrometry says the object is here, with a sliver of error. Radar says it is here, with another sliver and a slightly different mood. Thermal tracking whispers that surface heating added a nudge in this direction. None of them is wrong. All of them are incomplete. The estimator that fuses them carries a memory of past lies, a sense of how each sensor tends to exaggerate on a bad day, and a willingness to admit when a single odd point does not deserve the car keys. The momentum bonus from the plume has to be told where to sit. We do not measure it directly. We infer it from the way the path bends after the dance. Think of it as reading footprints in flour. A stronger kick means a path that opens more quickly. A weaker kick leaves you peering at the carpet for scuffs. Early numbers suggest the push exceeded the bare slap, which is good, but the universe fees its invoices in compound interest, not in confetti. The real prize is not the immediate kink. It is the gap that grows day by day as the tiny angle blossoms into a wide mist. The plot shows that bloom. It also shows the stubborn thread refusing to leave, now the uncomfortable arithmetic of risk. Probability is not a mood. It is a ratio between what we know and what we are honest enough to admit we do not. After impact, that ratio improves, but improvement is not immunity. The headline shifts from might to less likely, and the human brain tries to convert that into either relief or despair. The correct feeling is neither. It is a tension with better sleep hygiene. Inside the models are small traps with cute names and rude consequences. There are gravitational narrow gates that sit in space like toll booths. If the object slides through one, downstream paths bend more than intuition expects. Earlier, we worried about these in theory. Now we check them by name and date. Most gates are avoided by our new path. One gate still lines up with the obstinate thread. This is why the line refuses to die. The math is not threatening us. It is simply honest about where the map still folds. To turn uncertainty into action, the team launches a Monte Carlo swarm, which is a fancy way of saying we roll a very large number of plausible universes and count how many end with a sigh of relief versus how many end with an insurance claim no one wants to file. Each roll tweaks the starting conditions inside their measured wiggle room, then lets physics drive. Results spill across screens like confetti on a windy day. The tally gets better with each new measurement, but one pile of tiny, annoying outcomes keeps landing on our lawn. The immediate instinct is to ask for more data, and the sky is happy to provide, if you are polite, persistent, and carrying snacks for the night crew. We schedule additional radar passes to squeeze distance error, and we beg the weather to cooperate. We choreograph a series of optical images at angles that amplify parallax, because geometry is a generous friend when you set it up properly. Each new point is a stitch in the uncertainty cloth, drawing the fabric tighter until the loose threads have nowhere left to nap. Meanwhile, modelers attack the assumptions. What if the surface patch we struck opened a half-asleep vent that adds a whisper of thrust in the late afternoon on the object's local time? What if the spin changed just enough to alter which patches see heat first? These are not plot twists. They are maintenance on truth. The state of knowledge is a living thing, and tonight it is eating well. The scoreboard that matters most is dull on purpose. Projected missed distance at the critical passage, with honest bars showing what could still wobble. Day 1, after the hit, the bar grazes the safety margin. Day 2, it lifts a little. Day 3, it lifts a little more, and crucially, narrows. The stubborn line remains, but thinner, as if embarrassed to keep haunting us. Jokes in the room refer to it as the ghost corridor. The jokes are short. No one likes the ghost. Communication teams translate all of this without turning it into a soap opera. They avoid words like win and loss. They say trend and confidence. They publish the how as well as the what, which instruments contributed, how the fusion works, why one more night of data is not stalling but sharpening. The public learns a new patience that feels suspiciously like maturity. That might be the quietest victory of all. There is also budgeting in the background, the kind that buys options. If the ghost corridor refuses to vanish by a certain date, a follow-on burn by the chaperone might be justified. That decision has a deadline stamped on it by launch mechanics, fuel margins, and human stamina. The choice is not drama, it is scheduling with a side of courage. The meeting where this is discussed has more water bottles than rhetoric. By week's end, the map looks different enough to change the taste in the room. The main fan of futures sails cleanly wide. The ghost corridor shrinks to a hair, then a thread, then a whisper that statisticians argue over like art critics. You can feel shoulders drop even in silent screenshots. We moved the mountain, not by a canyon, by enough. Usually, enough is plenty, and yet the chapter title was not kidding. Space teaches humility with excellent timing. Success can be real and still not be final. There remains the late game card nobody wants to touch without cause, the one that trades elegance for decisive shove if the numbers refuse to behave. We are not there. We may never be there. But the next chapter opens the door carefully to the loud option on the table and what it would mean to choose it without turning one problem into a constellation of smaller ones. Chapter 14, the loud option on the table debate, turns to nuclear standoff techniques in the vacuum of everything. Detonation standoff distances, surface ablation, and non-fragmentation strategies get their clinical walkthrough. The ethical slider goes uneasy. The stakes push it anyway. Humor returns just long enough to say, please do not turn one problem into a confetti festival. First, strip away movie expectations. There is no sound in this theater, no rolling fireball making soaring violins work for their paycheck. In space, the useful part of a nuclear device is a flood of light and fast particles that arrive before anyone can finish the word consequence. If that flood touches the surface from a safe distance, it flashes a thin skin into vapor. The vapor rushes away, and by the quiet fairness of action and reaction, the rest of the body is nudged in the opposite direction. Think of it as turning a patch of crust into a jet for a heartbeat. The trick is to choose a distance that cooks the paint without smashing the car. Detonation distance is the first knob. Too close, and energy digs deep, cracking and flinging mass like a thrown plate. Too far, and the light fades to a rude sunburn that does not push enough. Engineers sketch ranges where the radiant dose at the surface is strong enough to make a thin sheet leap off, but not so strong that slabs break loose. The safe band depends on size, composition, and the pose of the target. If the surface is crumbly and dark, it soaks up energy and responds with a generous puff. If the surface is shiny or coated with glassy crust, more distance is needed to spread heat and prevent chips. The guidance computer would love everything to be simple. The surface declines that invitation. Energy delivery can be shaped by design. Devices can emphasize the intense flash of light that heats the top layer rather than deeper punch. In the vacuum, there is no air to absorb energy and become the famous mushroom. The focus is on coupling to the surface through light and fast particles that do not wait around. Multiple small bursts spread along a track can sum to the same push with less risk of a single ugly fracture. Imagine tapping a stubborn jar at several points instead of whacking it once and wearing pickles. Non-fragmentation strategies. Read like a list of polite habits for loud tools. Aim at the side, not the nose, so the nudge bends the path rather than tries to stop the train. Use an array of modest devices timed like a metronome, letting each puff add direction without waking deep stresses. Keep the device outside the debris cone so the craft does not take a gravel shower. Choose a standoff that maximizes gentle peel rather than violent bite. All of it is the same plea in different outfits. Change the trajectory. Preserve the patient. The political room is colder than the engineering bay. Treaties hum in the background like a chorus that refuses to leave. Testing bans, space law, assurances made in calmer decades. None of them designed for this exact page of history. All of them relevant in spirit. The case for an exception must be made with the precision of surgery and the humility of a librarian. Who decides, who verifies, who watches, and who promises this is a one-time permission slip for a very specific emergency? The paperwork would bore a comet. It must not bore us. Command and control becomes the heaviest phrase in the building. Devices that loud travel with rituals, custody logs written like novellas, locks that require several human keys in several human hands, and a chain of authority that is both clear and able to pause 5 minutes before ignition if new truth appears. The launch platform needs its own restraint. If space is the stage, the actors could be a fast rocket, a high-altitude aircraft, or a ship at sea with an eye on a sky that will not sit still. Any of these options arrives with neighbors who would like reassurance that this loud tool is aimed at a rock, and only at a rock. Side effects earn their own slide deck. There is no atmospheric blast in space, but there is a burst of light that could blind an unprepared sensor, and a cloud of energized particles that could nudge nearby electronics into nonsense. The operation would carve a no-fly, no-stare zone around the event for a short window, and satellite operators would be told to look away or shield sensors. Engineers calculate how much dust will be lofted and how long it will loiter, because you do not want to turn an interstellar visitor into a long-term grit factory in busy orbital lanes. And while the device itself does not paint the cosmos with lingering poison, the way myths suggest, any freshly liberated material gets tracked with the same fervor we reserve for wayward toddlers and borrowed cars. Ethics is not a soft subject here. It is load-bearing. The core question is ugly and honest. Do we accept the risks of a loud, decisive action to prevent a low but non-trivial chance of devastation? Or do we hold the line until quieter options are exhausted by the clock? People around the table speak in complete sentences. Some focus on stewardship, do not normalize bright tools for problems that patience and early detection could handle next time. Others stress duty. When a planetary risk is on the board, use every instrument in the cabinet, then put it back with a receipt and a vow. The compromise position is careful. Prepare the loud option to the point of confidence, but only cross the last bridge if measurements make that bridge the only sane path. The public conversation needs its own honesty. A briefing notes that there will be no fiery ring in the sky, no roaring at the horizon, and that the goal is to change a path by a whisper that adds up to a safe tomorrow. It explains that fragmentation is a failure mode, and that the plan is specifically designed to avoid it. It lays out oversight in plain words and shows who can say stop and how late that stop can still be meaningful. The cat graphic does not make an appearance here. This is not a cat moment. This is the moment of quiet, adult language. In the control rooms, procedures bloom on screens with the calm precision of checklists at a hospital. Simulations run through late aborts, misfires, and boring success. Boring success is the best kind. A final rehearsal pauses at every fork and asks, who speaks, who listens, who verifies? Nobody gets a hero line. The goal is a chorus that lands on the same note, then goes home to sleep. If the vote ever tilts to go, the last act is strangely uncinematic. A device rides quietly to a point in nothingness. A timer or a distant voice nods, and a flash writes a line of new math on an ancient rock. Telescopes blink. Models adjust. The red ellipses on the map slink away like chastened punctuation. With luck, no one on the ground notices anything more than a terse update and a world that keeps its usual color. We are not at that threshold, and we may never step over it. But having the loud option prepared changes the geometry of fear. It says we can be careful and ready at the same time. Next, we turn from the tool to the theater around it. Even without a strike, a near pass can rattle skies and orbits. The planet must rehearse its own choreography. Tides in the air, satellite dodgeball, and airlines learning new lines before the bass drop. Chapter 15, Tides in the Air. Earth responds before arrival. Even without a hit, a near pass can rattle things. Meteor storms, electric sky glow, and satellite dodgeball. Agencies rehearse orbital ballet, while airlines file new routes like nervous birds. The planet behaves like a concert hall, waiting for the bass drop. The first rehearsal cue comes from dust. Interstellar travelers do not always travel alone. They shed crumbs and threads that trail along the approach like glitter from a parade no one scheduled. When those grains intersect Earth's path, the upper atmosphere becomes a stage for fast streaks that carve brief scars of light. Forecast maps that usually talk about rain now include forward cones for pebbles moving faster than common sense. Night shift meteor networks spin up, ready to count and classify. If the stream is dense, the word shower graduates to storm, and binoculars become the most democratic scientific instrument on the planet. Romance meets physics. People hold hands under a sky that is, technically, throwing sand. Meanwhile, the ionosphere hums. A nearby passerby can tweak electric fields and prompt sky glow at strange latitudes, as if the aurora decided to try on a new outfit. Radio operators notice first. Signals that once skimmed cleanly across the night begin to fade and flutter. Navigation receivers complain about scintillation, the fancy word for twinkle, except your plane does not care for poetic synonyms when it wants a clean lock. Ground controllers roll out pre-written advisories. Expect noisy skies at these hours, route messages through quieter bands, and ask your instruments to count to 10 before believing everything they hear. Up in low orbit, traffic looks both ways, and then looks again. Conjunction screens swell with possibilities as the visitor's wake jostles the neighborhood. Operators perform a jittery minuet, gentle burns to sidestep predicted passes, then more burns to return to the original lanes. The choreography resembles city streets after a parade, all careful merges and polite impatience. Mega constellations add a special challenge. Thousands of craft cannot all duck at once, so managers prioritize moves by risk and mission. The guiding ethic is simple and stern. Do not trade a near miss for a debris field. Dodge early or not at all. Satellites that stare outward for a living embrace defensive postures. Delicate sensors tilt away to avoid surprise glare or stray ejector. Cameras adopt shutter rituals that tolerate brief flashes without throwing software into existential crisis. High-value hardware may even go quiet, saving precious margins for the day after. Safe mode becomes a household word in operations halls. A bit like a power nap for machines that refuse to admit they are anxious. Airlines rehearse their sky waltz with paperwork and fuel. Routes shift away from the slender probability bands. not because a pebble aims at a jet, but because climbing through upper air with uncertain radio clarity and a distracted satellite link is a poor hobby. Polar paths in particular get second looks. If upper atmosphere weather threatens to rattle communications, flights lean south, trading time for calm. Dispatchers juggle the geometry of time zones, airport curfews, and crews who deserve a schedule that is not a performance art piece. The notices read dryly, the ripple effects do not. 1,000 itineraries become small poems about caution. On the ground, power grids practice their stoic face. Operators adjust sensitivities, ready to accommodate small current drifts if the sky decides to speak in electrical hints. Transformers that would prefer calm are given a quieter diet for the weekend. Utilities dust off the playbook for geomagnetic fuss, just in case. The goal is not heroic defense. The goal is fewer alarms and a Monday that feels routine. Telecommunications hubs revisit redundancy like chefs tasting the soup one last time. If a satellite link wobbles, fiber takes the baton. If fiber stumbles, microwave relays stand up straighter. Critical services get temporary shortcuts that bypass decorative features and head straight for useful. Emergency managers also wargame. A modest but real possibility, a short burst of falling debris that does not reach the ground but leaves dramatic sound over a corridor. The answer is simple instructions in many languages shared ahead of time, so the neighborhoods under that ribbon know the difference between spectacle and danger. Astronomy, oddly, thrives. Observatories schedule special runs to watch how the visitor's near pass paints the sky. Long exposure images rake the dust for structure, looking for braids and kinks that tell a story about earlier outbursts. Radio dishes listen for faint pings off small fragments, the way a bat hears the world through its own questions. Amateur networks participate with surprising rigor, sending time-stamped records that, when stacked together, act like a continent-sized instrument. The sky is generous to communities that share. Ships at sea join the chorus, not because they expect a splash, but because open water is a mirror for strange air. Radar on bridge towers can pick up brief clutter if the upper layers ripple. Captains are briefed to expect the occasional phantom squall on a clear night and to trust their eyes over a single stubborn screen. Harbor pilots make the quiet, pragmatic choice to extend windows for arrivals and departures in case delays ripple around the clock. Ports are where schedules pretend to be laws. Tonight, they practice being suggestions. In classrooms, teachers turn a forecast page into a lesson. Paper confetti becomes a model of dust dispersion. Flashlights and chalk show how angles decide whether a grain blazes or whispers. A student asks whether an interstellar visitor sees our sky as beautiful. The teacher says, beauty is mutual when the math fits. Homework is watching the night and writing about it in present tense. The grades will be kind, the memory will last longer. The cultural weather changes too. Musicians schedule pop-up sets under dark parks because nothing pairs with meteor light like a low chord on a cello. News anchors learn to say ionospheric without making it sound like a villain. A street artist paints a mural of Earth leaning back, while the sky leans in, captioned, "Close is not the same as harm." For once, the comments agree. All the while, control rooms keep their posture. Calm shoulders, precise verbs. They post updates that sound like tide tables. Expect increased activity between these hours, reduced interference thereafter, further assessment tomorrow. It is not poetry, and it does not need to be. If civilization is a stack of interlocking habits, then this is us rehearsing together. The drill is the performance. When the visitor finally sweeps past and the lights in the upper air settle, a strange quiet lands. No grand finale, just instruments returning to their key signatures. People shrug and put away blankets. Pilots thank passengers for patience that, frankly, outperformed expectations. Engineers slide checks back to nominal. The concert hall holds its breath one last time, then releases it, Which brings us to the final movement. We have steadied the hall, tuned the instruments, and played through 2 acts. Now comes the tightest cue, the last correction, the last vote, the last nudge that decides which story we tell tomorrow. Chapter 16 steps into that longest night, where a second mission closes in, and the planet measures courage in millimeters. Chapter 16, The Longest Night, Final Burn, Final Vote. A second mission closes in, with a last, elegant push, a side glance worthy of a pool shark. The detonation stays a backup. The kinetic duet sings instead. People gather outside, because that is what we do when fear and wonder share a seat. The spacecraft wakes from its last planned nap and stretches with a roll that brings star fields into the star trackers like familiar faces at the end of a road trip. It has one job left: lean on a moving mountain, so gently that tomorrow exists exactly where we want it. The burn is tiny by movie standards. By consequence standards, it is a lever under a planet's future. Inside the flight dynamics room, voices shrink to the size of needles. A guidance lead rehearses the count in a tone that could calm a thunderstorm. The trajectory screen shows a pale thread kissing a thin, shaded boundary called enough. Enough is not a word you want to negotiate with at this hour. The plan is to place the impact not at the center of mass, not at the limb, but at the sweet off-center zone that promises direction without drama. The main engine will never fire. This is a tap dance with ankles of compressed gas and valves that have never missed a beat. Across town, a room that smells like fresh paper and nervous pens convenes the final vote. Representatives from agencies, regions, and those who signed for big budgets take their seats. The backup plan sits on the agenda like a thundercloud no one wants to describe. The numbers on the screen are good. Good does not equal certain. A meteorologist once said forecasts are good ways to be right politely. Tonight, polite right must become exact enough. They go around the table, yes, 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 one measured yes with a note about oversight. The chair signs with a pen that has been waiting for this particular signature for weeks. Back at the dish farm, the network switches to high alert. The main antennas swing, smaller siblings point and hold their breath. Operators lock in the frequency that carries the craft's heartbeat, as if tuning an instrument before a solo. The link margin is healthy. Nobody says the word jinx, but several people think it with such intensity, the thought probably needs a caffeine break. On the pad of Earth, night has pulled a blanket over cities and left pockets of quiet. Parks fill with families who should be asleep and are, instead, practicing the ancient ritual of staring at the sky for meaning. You can tell who did homework. Someone points out where the dim visitor should glide. Someone else explains that you will not see collision, only trust. Snacks appear as tribute. A dog keeps watch, as if volunteered for the role of morale officer. A teenager narrates for a tiny audience on a phone and signs off with a grin that says history tastes like cold air. The spacecraft pivots to the pre-burn pose. Thruster temperatures read like a chorus line in tune. Tanks register the final sips. The burn plan is brutally simple, 3 pulses, separated by the time it takes the craft to twist a few degrees, each one timed against the target's rotation, so the hit lands where geometry wants it. This is less an attack and more a nudge written in cursive. Mark, says the loop. A pulse whispers. Numbers respond with a small, satisfactory slide. The craft rolls. Mark. Another whisper. The guidance plot shows the aim point settling like a coin on a bar top. A third pulse waits in reserve. The goodbye tap. If the second did not quite tuck the bowling ball into the right lane, on the visitor, the chosen patch rotates into the crosshairs, like a character making a precisely timed entrance. It is a plain section, boring by postcard standards, a slope with texture like stale bread, no cliffs, no obvious vents. Boring is beautiful to people who wager spacecraft on adjectives. The chaperone from the earlier mission loiters at a respectful distance, ready to be the eyewitness that does not blink. Down on Earth, The vote room morphs into a listening theatre. The chair who signed the go now stares at a graph as if it were a newborn. Beside them, an ethicist who argued for reversible steps earlier now murmurs, "May our caution age well." This is what passes for a prayer in a room full of people who trust the universe but verify. 2 minutes to contact, says the loop, like someone announcing last call in a library. The public stream switches to a clean animation and a caption that refuses to overpromise. No one imported a countdown clock with dramatic bleeps. The only sound is the small tidal noise of chat messages flowing past. Greetings in a dozen alphabets, a child's good luck drawing, someone posting the cat graphic for courage and getting gently shushed. Impact is not visible, again, and yet it lands. Telemetry burps a signature that the guidance team has spent months learning by heart. The craft's accelerometers spike like a plucked string, then settle. The chaperone's camera records a short exhale of dust. Modest compared to the first mission, perfect for the purpose. Not a bruise, a suggestion. 2 seconds later, the final pulse is cancelled. The second was enough. For once, enough feels generous. The math engines breathe in the new data and begin their unromantic waltz. Doppler shifts translate into delta, angles fold into error bars, light takes its sweet cosmic time to reach the receivers. A tiny adjustment on the plot thickens into conviction. The shaded boundary called enough becomes a margin called tomorrow. No one cheers yet. Superstition is the umbrella you carry, so it will not rain. Outside in the park, the host of the tiny phone stream reads the official line as it arrives. Contact confirmed. Tracking nominal. Assessment in progress. The crowd claps anyway, a soft ripple that confuses the geese. Someone starts a song quietly off-key and does not finish it, because a streak just arced and everyone gasped at the wrong thing for the right reasons. People are like that. It is our most adorable bug. In the control room, the mission director signs the last line of the last checklist, a junior engineer who wore the same sweater for every critical event, puts it in a bag and says it can retire now. A propulsion lead writes 3 words on a whiteboard, small, on time. That could be the motto for civilized effort. We do not need to be grand. We need to be precise. Messages flash along the interagency cables, stand by for revised corridor maps. No activation of the loud backup. Maintain satellite avoidance plans for the next orbit day, just in case. Airlines get the news that their cautious detours may relax at morning. Grids prepare to return sensitivities to ordinary. Teachers prepare to throw out tomorrow's lesson plan in favor of something called living memory. The night grows older than it has any right to be. Somewhere, a grandmother tells a sleepy kid that sometimes the world is saved by whispers. The kid asks if rocks can say thank you. The grandmother says we will take the thank you as silence. By dawn, the first clean solutions will arrive. For now, the planet sleeps with one eye open and a hand on the radio exactly as it should. Next chapter, the numbers stop flirting and commit. The path of 1,000 miles, shifted by a whisper, and the strange human feeling when disaster misses by the thickness of a thought. Chapter 17, Path of 1,000 miles, shifted by a whisper, telemetry locks, the new orbit misses, not gloriously, not by a movie mile, but by the quiet, perfect space between disaster and tomorrow. Cheers erupt, somewhere a spreadsheet cries happy tears. The sky looks the same, we do not. Morning begins with confirmation, dressed as modest numbers. Ground stations hand off the baton around the world, and every pass repeats the same pleasant refrain. The visitor will thread the solar lanes past us, grazing nothing but our nerves. The first plots look like tidy sewing. One line labeled was, one line labeled now, and a comfortable gap that fits a planet's worth of relief. No confetti cannons, just a chorus of exhalations disguised as keyboard clicks. Certification comes the way trust always does, in layers. Independent navigation teams run their own solutions. quarrel with their assumptions, then swap the results like recipes and try again. A radar pass from a dish that once tracked lunar echoes chimes in with a range that agrees down to a sliver, so small you would need a jeweler's lope to see the disagreement. Optical astrometry seals the deal with a set of points that lie exactly where the new path predicted they would be. Agreement is not dramatic, but it is delicious. The last red ellipse on the global map fades to a color better known as normal. The ghost corridor we argued with for days is archived like a retired villain in a novel that chose a happy ending. The Mission Channel posts a line that will be quoted for years, risk reduced to background. Not zero, nothing worth knowing is, but so thin that you would have to squint at the universe for a very long time to worry about it. Celebrations unfold quietly, feral. Someone opens cookies, shaped like tiny spacecraft, and insists the crumbly ones are realistic. The propulsion team takes the world's shortest victory lap, around a conference table, and nearly collides with the communications lead, carrying a box of paper crowns. A guidance analyst saves a screenshot of the final plot in a folder named Do Not Delete under any circumstances, which is the modern equivalent of framing a diploma. A janitor pauses, listens to the muffled joy, and nods like a person who has seen better and worse and knows the difference. Outside the labs, relief ripples through ordinary life with the speed of gossip and twice the nutrition. Airlines roll their routes back toward efficient. Satellite operators peel their hardware out of careful crouches and stretch solar wings back to sunward elegance. Power grids shift from watchful to routine. In parks where people kept vigil, leftover thermoses trade owners and strangers who learned each other's first names at 2 a.m. practice the rare art of unawkward goodbyes. The planet returns to its habits, but not to its old innocence. It has a new scar you cannot see, and a new confidence you can feel. There is the count of what worked. Early detection turned nights into usable days. Cross-checks between very different instruments pinched uncertainty until it squeaked. The patient cadence of updates stole fuel from rumor. Engineers built machines that could fly straight and tap lightly, a choreography that rewarded restraint over spectacle. And the world learned to stand in a common doorway and look out together without shouting over the view. There is also the list of almosts, which matters as much. Almost launched the loud card. Almost clipped a narrow gate in the gravity garden. Almost let a corridor linger longer than comfort should allow. Almosts are not failures. They are highlighters on a page titled Do Better Next Time. They are the reason checklists grow wiser and hardware grows modular, ready to become something else on short notice. They are why budgets will include shelves for parts that sleep until needed and wake without drama. Scientists squeeze the moment until new knowledge drips out. The deflection taught how certain surface textures breathe when stressed, how dust settles into patterns that reveal unseen layers, and how a spin remembers being persuaded. Papers begin their slow migration from draft to journal. Conferences will show slides where the before and after look almost identical, and yet the captions will make people lean forward. That is the grammar of space. Tiny edits, huge implications. Human stories accumulate like souvenirs in pockets. A school posts a bulletin board filled with crayon drawings of a planet dodging politely. A hospital night shift decorates a whiteboard with a timeline showing when the worry peaked and when the sighs began. A radio host who explained momentum using a rolling office chair is invited back for a segment on relief. A grandmother teaches a child a new word, reprieve. The child teaches the grandmother a newer one, viral, but for good. There is a strange sadness tucked into relief, and it deserves a seat. When the storm swerves, the adrenaline that kept everyone tall has nowhere to go. The hands that built checklists feel a slight tremor when they set the lists down. The trick here is grace, acknowledging that effort is real even when the worst thing does not happen. The medals are quiet. A well-slept night, a calendar not erased, a schedule that clicks back into place with only a few squeaks. Policy wakes to opportunity. Lawmakers who spent the last week on a steady diet of briefings now speak in sentences about survey coverage, data sharing pacts, and rapid assembly of nudge kits. They sound less like people auditioning for drama and more like people paying for good plumbing. The document titled After Action sits on a screen while pens hover, then begin their slow dance across the page. Bureaucracy gets a harsh reputation, but on days like this, it is the muscle that remembers the move. The visitor itself slides on, indifferent to applause. It will spend years turning sunlight into faint warmth, and faint warmth into tiny adjustments, writing a long, quiet autobiography that no one will read in full. Somewhere, in a dataset, the lines we drew today will still be visible, a notch in a page of motion. We gave it a suggestion. It took it. That is enough narrative for a rock. The sky tonight will look unremarkable. All the same stars will hold their places like disciplined extras. Yet, anyone who watched will see a little more than points of light. They will see a margin hard won, a map redrawn, and a species that chose to be careful quickly. That change is not visible to cameras, but it is visible to us. Humanity learned a small lesson with large handwriting. There are futures you earn by being early and gentle. Tomorrow, the debrief begins. Debriefs are not glamorous. They are how civilization edits itself. We will count our wins, admit our luck, and print the new playbook with margins wide enough to keep writing. And then we will turn to the last chapter, where we ask what to build before the next unknown arrives. Surveys sharper, missions quicker, and a culture that treats preparedness as ordinary. In other words, how to live after the visitor. Chapter 18. After the visitor. Manuals for the next unknown. Debriefs turn into doctrine. Survey more, share faster, design modular, keep options on the shelf, and the politics out of the toolbox. The public memory reframes the cosmos, not hostile, just indifferent, which is a better reason to be clever. The final wink, when the universe throws a curveball, bring a bat, a notebook, and a sense of humor. Next up, we follow the fragments into deep space and ask what secrets the dust remembers. The first hours after relief taste like victory with paperwork. Every console printout becomes evidence. Every scribbled margin note becomes a breadcrumb. Teams reconstruct the timeline like watchmakers pulling apart a clock to admire the springs. Which alert arrived when, who called whom, where the model bent, and where it held. There is no blame hunt, only a scavenger hunt for speed. Doctrine begins with a vow that reads almost like poetry. When the sky speaks quietly, we will hear it early. Surveys get the loudest upgrade. Telescopes that stitched the night into neat quilts will now stitch faster and deeper, swapping old cameras for hungry ones and teaching algorithms to spot shy intruders that pretend to be noise. Coverage goes global without gaps, because gaps are where tomorrow hides. A new cadence emerges. Twilight searches for objects, sneaking in sunward, pre-dawn sweeps for the faint and fast, and southern and northern networks braided so clouds cannot hoard the plot. The funding pitch is refreshingly honest. Think smoke detectors for the solar system, but with better views. Data stops acting like an introvert. The clearinghouse that once needed gentle prodding becomes a torrent with rails, shared formats, common timestamps, automatic provenance tags that ride with every pixel. An alert that used to wait for a human hand now sprints, annotated by machines trained to whisper probabilities without swagger. The password to this party is competence, not nationality. Everyone can see enough to help. Everyone who can help sees more. Share faster is not a slogan, it is plumbing, and we fix the pipes. Spacecraft design goes on a diet of modularity and off-the-shelf parts that do not sulk when bolted to new ideas. Think shelves labeled nudge bus, sensor nose, relay tail, ready to be mixed like emergency Lego. Thruster pods standardize, so a guidance brain can speak fluent thrust, no matter who built the valves. Star trackers learn to boot like sprinters. Even the fairing interface gets a makeover. Fewer bespoke bolts, more universal hugs. The goal is not one perfect craft. It is a family of good enough siblings who can be dressed for the occasion in days, not years. The romantic myth of bespoke hero ships retires, graciously, with a cake in the break room. We also store options the way prudent households store batteries. A small stockpile of critical components, radiation-tolerant chips, reaction wheels, propellant feed lines, sits in clean, boring rooms guarded by databases that test them on a polite schedule. A dormant engine is like a violin. It hates neglect. So the shelves hum with periodic wake-ups that say, "Yes, I still sing." The world discovers the thrill of logistics done well, which is less thrilling than fireworks and far more useful. Exercises become culture. Once a year, the planet runs a tabletop where the dice are weighted toward mischief. Mayors, pilots, translators, and mission controllers meet in rooms that smell like coffee and dry erase ink, and they practice being one voice without being one uniform. The rules are simple: no invented drama, no heroic speeches, and 3 rehearsed versions of the sentence we do not know yet. And here is when we will. Kids join these drills at school with paper comets and kitchen timers, because preparedness that starts in childhood grows up into calm adults. Ethics gets a chapter, not a footnote. A standing council with engineers, lawyers, philosophers, and people who spend their days fixing things without headlines, drafts, bright lines. When loud options are considered, who watches the watchers, who signs, and who can say stop? The document reads like a careful handshake between urgency and restraint. It balances duty to protect with the promise not to normalize spectacle. The loud tools stay on the shelf with the safety on and an instruction manual nobody treats as fiction. Communication keeps its radical clarity and writes it down as policy. Plain language becomes a requirement, not a courtesy. Graphics earn user testing the way parachutes do. The beloved cat animation that explained momentum gets a sequel, explaining uncertainty, this time co-starring a turtle who refuses to rush conclusions. The point is not cuteness, it is comprehension with staying power. Media literacy finds its way into curriculums beside reading and arithmetic. How to spot a rumor, how to follow a source, how to be brave without being loud. Citizen science, having proved it can carry weight, gets a better toolbox. Backyard observers receive calibration kits, time sync beacons the size of mints, and tutorials that treat amateurs like colleagues. A kid with a second-hand telescope can still put a point on the board. Now that point arrives with certified timing and error bars that make statisticians smile. When the next whisper appears, the world does not just watch, it measures. We build archives meant to outlive fashions. Every light curve, radar echo, thermal whisper, and panicked doodle is preserved with context sharp enough that a researcher 20 years from now can relive the night without guessing what weird hump afterburn 2 meant. Museums curate an exhibit titled Margin, where visitors walk beneath a suspended line representing missed distance and realize that sometimes safety is measured in whispers, not walls. The gift shop sells notebooks, not plush rocks. Culture absorbs the lesson in sly ways. Science fiction trades doom for competence drama, showing teams who argue kindly and save the day by doing math with clean hands. Musicians write songs where the chorus does not explode, it resolves. A comedian coins a line that becomes a bumper sticker. We do prevention now. People laugh and then nod, which is the healthiest laugh. Finally, budgets grow spines. Money promised in relief gets converted into money scheduled in spreadsheets. A small permanent tax on complacency funds, surveys, rapid kits, drills, and the emergency postage required to move courage quickly. It is not glamorous. It is how we promise ourselves we will remember. So the manual settles into place. Watch wide, speak plain, decide early, design adaptable, stock quietly, rehearse together, and let ethics ride shotgun. The cosmos has not changed temperament. It never wanted to scare us. It simply forgot we were home. We changed, which is the only lever that ever mattered. Next up, we keep our promise to curiosity instead of fear. We follow what the visitors shed, filaments, motes, and crumbs into the deep to learn what those tiny archives recorded on their long, starlit journey and what secrets the dust remembers.